Let's talk about finding domain and also combinations and compositions with functions. Here we've been given two functions. F of x is 2x plus 1 and g of x is 4x minus 3. First, let's see if we can find the domain of f of x. At this point in the semester, the only things that we know of that restrict a domain, you can never have 0 in the bottom of a fraction, and a square root can never have something negative under it. So as we look to see about the domain of just f, only this function, we're asking ourselves, is there a fraction? Is there a fraction? No. Is there a square root? When you look at f, is there a square root? No. Since neither of the things that we know of that restrict domain happen in f of x, this means that our domain is all real numbers from negative infinity to positive infinity. Same thing with g of x. There's not a fraction, there's not a square root, so from negative infinity to positive infinity, all real numbers would be our domain. Remember, when we have an infinity, we get parentheses beside it. And remember also that the smaller thing goes on the left with the larger thing on the right. Now, let's look at a combination of these two functions. The first combination, addition. When we want to know f plus g of x, all that means is let's take the one called f, which was 2x plus 1, and let's add to it the one that is called g, which is 4x minus 3. Now, I don't really need those parentheses there. If you take them away, we're just combining like terms. So 2x plus 4x made 6x, and 1 plus this negative 3, 1 minus 3, made negative 2. Now, if you were to ask yourself about the domain of our sum, 6x minus 2, do you see a fraction? Do you see a square root? No, in both cases. So the domain is again from negative infinity to positive infinity. Let's look at our second combination, which is subtracting the functions. Just like you may have guessed, subtracting f minus g of x means take the one called f minus the one called g. Now, this time we have to be careful with the subtraction that we distribute this minus sign into the parentheses, changing both signs back here. So as I remove the parentheses, let's bring down the 2x plus 1. The opposite of 4x is minus 4x. The opposite of negative 3 made positive 3. Now we can put the things together. So 2x minus 4x made negative 2x, and 1 plus 3 made 4. If I asked you the domain of this one, is there a square root? Is there a fraction? There's not. So the domain is from negative infinity to positive infinity. Next, let's see if we can find the product of these same two functions, f and g. When we do the product of them, since it's a binomial times a binomial, we'll need to FOIL these things. It's 2x times 4x, the first ones. 2x times 4x gave me 8x squared. When I do the outside things, 2x times negative 3, that's minus 6x. Then on the inside, negative 1 times 4x made negative 4x. Negative 6x minus 4x gave us negative 10x. Then the very last ones, negative 1 times negative 3 made positive 3, just FOILing those two binomials. Is there a fraction or a square root? There's not. So the domain is from negative infinity to positive infinity. This has a square, but it didn't have a square root. Squares do not restrict the domain. Only square roots restrict the domain. Let's look at our next combination, which is to divide these two things. When you say f divided by g of x, that means take the one called f, which was 2x plus 1, put it on the top. Take the one called g, that's 4x minus 3, put it on the bottom. Now, this time, as we think about the domain, have you got a fraction there? Yeah, the whole thing is a fraction. So the bottom of this fraction can never be 0. If it's 0, then we have an undefined expression since you can never divide by 0. So let's figure out what's going to make this 0. Take that stuff, set it equal to 0, and solve, adding 3, dividing by 4, and looks like 3/4 is the thing that would create a 0 on the bottom. So the thing that x cannot be is 3/4. Now, a little bit of a trick when we try to write the domain this time, since it's anything in the world except 3/4 that we can use, our domain goes from -infinity up to 3/4. You can't include 3/4, so parentheses there. Now, to join this set with another set, looks like a U, but this stands for union of the sets. We'll pick right up at 3/4 and go to infinity. Since we've got parentheses with the 3/4 in both places, that's telling us 3/4 is not included. So it's everything in the world except 3/4. One more thing for us to do, and that is the composition of these functions, f of g of x. Here is how I like to write f of g of x, but it can also be expressed with a circle between f and g. Now be sure that you see this is not multiplication. This is a composition of the functions. And what it means is we're going to take the one that is inside, in this case it's g, and we're going to substitute it into the other one. When it's written this way, it's the one that's at the back that we substitute into the one that's in the front. So a composition means substitute one of the functions into the other one. The thing that is inside goes into the other one. So I'm going to take this 4x minus 3, I'm going to substitute it for that x. The 2 that is here is the 2 that we have there. Instead of x, let's replace it with 4x minus 3, the stuff that was our g. And then this plus 1 is the plus 1 from the back of our f of x. If you multiply here, 2 times those things, you would get 8x minus 6. And when you add these like terms together, you end up with 8x minus 5. Now, when you look at 8x minus 5, do you have a square root or a fraction? You don't. So the domain is from -infinity to +infinity, all real numbers. You may sometimes be asked to evaluate at a specific spot. For instance, if we were asked to do f of g of 2, what that really means we should do is figure out what f of g of x is, and then take 2 and put it in for the x's that we see. When I take 2 and I put it in, I would have 8 times 2, which is 16, minus 5. 16 minus 5 gives me 11. That's technically what we're supposed to do. Find f of g of x, then substitute. But here's a neat little trick to know that may come in handy with harder problems. If you just look at the inside thing, g of 2, that says take 2 and substitute it here. 4 times 2 is 8. 8 minus 3 is 5. So this would be 5 if we substituted 2 into it. That means I've got here f of 5. If I do f of 5, 2 times 5 made 10, and 10 plus 1, that's still 11, isn't it? Sometimes it's easier to substitute and then do the composition rather than first doing the composition and then substituting, depending on what the problem looks like.